Welcome to The Explainer. Today we're diving into something seriously cool, the Sentinel of Intelligent Flight. It's a next-generation AI drone that's currently being developed in a highly futuristic research lab. If you've ever found yourself wondering just how close we actually are to fully autonomous robotics, well, you're in the right place. We're going to break down the massive amount of innovation packed into this single, incredible device. The source material kicks things off with this amazing scene. Engineers activating the drone, while these glowing blue energy lights pulse right across its chassis. It's definitely a deliberate design choice, meant to signal the awakening of a machine that its creators are literally calling the future of intelligent flight. It really sets the stage perfectly for a device that's so heavily focused on cutting-edge engineering and advanced capabilities. Section 1. Meet the next-gen Sentinel, Anatomy of the Drone. So let's start with the physical hardware. These traits completely combine to create a highly deployable tool. First off, the body's built from carbon fiber. And as you probably know, carbon fiber is renowned for its insane strength-to-weight ratio, which protects the drone without constantly draining its battery. Pair that with foldable arms, and you can easily pack this whole thing away right into a backpack. Plus, instead of that loud, annoying buzz you get with traditional drones, this one uses silent electric rotors, making it super unobtrusive. And finally, the ultra-fast wireless charging means it can literally land, recharge in an absolute flash, and get right back up in the air. But the physical build is really only half the story. The digital senses are what actually make it so smart. It utilizes LiDAR, which if you're not familiar, uses lasers to map out physical geometry in full 3D, right alongside thermal and night vision cameras that can easily detect heat signatures in absolute pitch darkness. And for the operator, the source note's a holographic control interface. Yep, replacing your traditional clunky remote with three-dimensional spatial computing. It is just a fascinating look at the conceptual direction of human-machine interfaces.
Section 2. The Brain. AI and autonomous navigation.
Now, the absolutely crucial point here is that this drone actually thinks for itself. By utilizing AI-powered autonomous navigation, which is fed by all those LiDAR sensors we just talked about, it achieves full 360-degree obstacle avoidance. Think about how incredibly difficult it is to fly a regular drone manually in a really tight space, right? Well, this machine processes its environment in real time, mapping out the terrain completely autonomously. You literally don't have to worry about crashing it into a rogue tree branch or the side of a building. It sees the obstacle, calculates the physics, and automatically adjusts its flight path in mere milliseconds. It is entirely self-sufficient, reacting to the world exactly as it happens.
Section 3. Missions and Real-World Impact. So the source material actually charts a pretty rigorous stress test for these systems. First up, the drone navigates a smart city. That's a super dynamic environment, right? Just full of unpredictable movement everywhere. Then it dives right into a dense forest, perfectly testing its ability to weave through complex static obstacles, like tons of branches. From there, it ascends way up into snowy mountains, just to prove it can handle extreme altitudes and some seriously stark visual contrast. And finally, sweeping along coastal cliffs where unpredictable whipping winds really test its stabilization. And the crazy part? It charts its path through all four of these intense environments completely autonomously without hitting a single obstacle. And all those extreme stress tests? Well, they translate directly into some amazing real-world applications. By utilizing its advanced AI, the Sentinel can precision track moving vehicles. Or, when speed is absolutely critical, it can transport medical packages rapidly across those exact same challenging terrains we just talked about. And leveraging that thermal and night vision, it's totally equipped to assist emergency teams during high-stakes search and rescue operations. Finally, for industrial or even creative uses, the hardware is fully capable of capturing super detailed 8K cinematic footage at 60 frames per second. Talk about a multi-tool?
Section 4. The Future of Flight.
The source material actually leaves us with this highly detailed, stunning final scene, perfectly showcasing the whole concept through some seriously advanced digital rendering. The drone is hovering completely silently against a gorgeous sunset skyline. And this is all visualized using top-tier computer graphics techniques. We're talking volumetric fog, real-time ray tracing reflecting light right off the chassis, and high dynamic range, or HDR, lighting. It really serves as a brilliant visual summary, just this idealized digital look at exactly where mobility and artificial intelligence intersect. So, I want to leave you with a final, provocative thought for our explainer today. We've just explored a digital concept that seamlessly blends life-saving search and rescue capabilities, high-resolution cinematic 8K video, and flawless autonomous tracking all packed into one incredibly lightweight, completely silent machine. As all of these mind-blowing features converge into a single tool, what limits actually remain for intelligent flight?
Seriously, what new possibilities, new industries, or completely new horizons await us when the sky is no longer the limit, but just a starting point? Thanks so much for joining me on this explainer today, and hey, keep your eyes on the
Please like, share, and subscribe to my channel for more great content.